And if you think about what we've done previous to this, we know that the sine of u plus v, it's obviously this isn't u plus v, it's u plus u, but we can rewrite that or expand that to be the sine of u cosine of u plus cosine of u sine of u. Well, with our commutative property, those can be flip-flopped. So really what we have here is 2 sine of u cosine of u. And that's what our formula is for this one. So I'm just kind of showing you how we derive these and how we're coming up with these formulas. On our cosine, the cosine, we've got actually three different forms of the way that we can write it. So you think about just like what we just did with the sine. Cosine can be cosine of u plus u. And again, if we expand that, that is cosine u minus sine u sine u. Well, what's another way to write cosine u cosine u? That's cosine squared u minus sine squared u. So there's form number one for the cosine. Now, as we've talked about prior to this lesson, we know that cosine squared u, what's another way to write cosine squared u using our Pythagorean identities? And it's the same thing as 1 minus sine squared u. Well, if you put that together, that's the same thing as 1 minus 2 sine squared u. So that's our second way to write this formula. Then, as you can probably guess, we could also do the same thing with our sine squared. What's another way to write sine squared? So, cosine squared u minus, another way to write sine squared is 1 minus cosine squared u. So if you put that all together, cosine squared minus the negative cosine, that gives us 2 cosine squared u minus the 1. And that's the third way to write that one. Now, we're listing all three of them. Again, you can, as we go through our expansion, we start to do some of those problems in your practice. As we get into next week, you're going to be able to use whichever one of those you want to use. But I did want to kind of show you how we derive that. And then I'm going to do the same thing with your tangent, just to show you that before we look at an example. So tangent of 2u, just like with the previous two, we can write that as the tangent of u plus u. We learned this week that the expansion of that is tangent u plus tangent u all over 1 minus tangent u tangent u. So if you put that all together, the formula then for our double angle for tangent is tangent to tangent u over 1 minus tangent squared u. Now, I'm not going to derive for you the half angle formulas. Matter of fact, I've made the decision in talking with Miss Moore that on the half angle formulas, I'm not going to require that you memorize those. Okay, so those are going to be given to you. But just to kind of go through those here real briefly with you, sine u over 2 is equal to the plus or minus square root 1 minus cosine u over 2. I'm not going to read all those to you, but those are your half angle formulas. And again, we'll talk about as we start doing our expansion of these, there's a plus minus in front of those, and that will depend on what quadrant we're in or what the u angle is as to whether or not the plus or minus is a positive or a negative. And you don't need to worry about that today. We'll start talking about that a little bit next week. I do want to go through just a few example problems from your practice tonight. So I'm just going to pick a few just so you understand what you're doing with this. So if you turn to that page, the 1 through 27 in your packets, just so you understand how you're using these double angle formulas. So I'm just gonna pick a couple of these. So number one says sine of 2a, and it says expand each expression. Well, we know from our double angle formula we just derived that sine of 2u is equal to 2 sine u cosine u. Well, we're saying in this first one that a is the u value. So basically we're just going to say this is 2 sine of a cosine of a. That's really all we're doing with these for this practice. So we're not going to actually do the full expansion quite yet. For the cosine, we'll skip down to number 4. So on number 4 for cosine, we could say our u value is 53. So we could say the cosine squared 53 minus the sine squared 53. That would be one way to write it. If you use the second formula, it would be 1 minus sine squared 53. And if you chose the third one, 2 cosine squared 53 minus 1. Again, that would be all three of those. We'll do one of the tangents. How about number 5? So tangent of 2c, that would be 2 tangent c over 1 minus tangent squared c. So you're just doing your conversions on these. We'll do one of the half angle ones. So hopefully you get your formula sheet there for the half angle. How about if we do, we'll do one for cosine. How about number 9? Number 9 says cosine a over 2 So you're going to say plus or minus square root 1 plus cosine A all over 2. When you get to the bottom of this practice, pretty similar to what we did on the previous worksheet earlier in the week, it's a mix of a lot of your different formulas, just condensing it down to one function and applying your different formulas there. So you ought to be able to figure that out and really go through those. They're not long problems, but that is your practice to end the week here. This is finish this page 1 through 27. And then next week we will discuss how we take that a step further.